Rajan this side. Welcome to my YouTube channel. So today we will discuss all the 4 problems asked in today's LeetCode Weekly Contest 4/2. So let's start with the first problem. So it says you are given a matrix of size n cross m, and you are also given 3 integers x, y, and k. Now this x and y is essentially the starting cell of the submatrix of size k, right? So like essentially you have to form k cross k square submatrix whose starting cell is x comma y, right? X comma y. And now what you have to do, your task is to flip the submatrix by reversing the orders of its row vertically. Like for example, in this test case, your x and y is 1 comma 0. 1 comma 0 means second row first column, so this is your starting cell. Now k equals to 3 means that you have to form a 3 cross 3 matrix, square submatrix whose starting cell is 1 comma 0. So from 1 comma 0 the 3 cross 3 matrix is extended till here. So this is your square submatrix, so the starting cell is 1 comma 0 and the side length is 3, right? So what we have to do, we have to flip the submatrix by reversing the orders of its rows vertically. So essentially what we have to do, we have to go through each column, these 3 columns, and we have to reverse these numbers 5, 9 and 13. So it becomes 13, 9 and 5. Now similarly for the second column, once you reverse it, it will become 14, 10 and 6, and same for the third column, right? This is the implementation problem. Let's see how we can approach it. So we are given x, y and k, right? So let's consider this submatrix. This is a square submatrix of size k cross k. So your starting cell is already given, which is x and y, right? X row is x and column is y. So once you configure a k cross k submatrix, now your last cell, like the row and column of the last cell would be x plus k minus 1 and column would be y plus k minus 1, right? So this is your square submatrix of size k cross k. So what we'll do, we'll use 2 loops here. One loop will be used to go through each of this column from index y till y plus k minus 1, and now the inner loop will be used to reverse all these numbers present in that particular column, and the indices will be from x till x plus k minus 1, right? So let's see how we can write code for it. This is the code of first problem. So we are given grid x, y and k, right? So now for considering the k cross k square submatrix, your starting column is y and your last column would be y plus k minus 1, right? Y plus k minus 1. So I use 2 loops here. First loop is to go through each of this column. So column equals to y, column less than y plus k, column plus plus. Now for each column there are 2 things. One is the row up and row down, right? The first index and the last index in that particular column. So I have designated it as row up and row down. So row up would be x and the row down would be x plus k minus 1, right? Row up and row down. Now what we have to do, we have to just swap first and the last element and keep on updating row up and row down. So we have to do this process up till up is less than down. If that is true, just swap these 2 numbers, right? First and the last number, and after swapping just update your row up. So row up would be row up plus plus and row down minus minus. So what this does exactly, so let's say you have to reverse these numbers, right? So let's say this is my first and this is my last. So once you swap these 2 numbers, what we have to do, we have to swap the second and the second last number, right? So your up would be plus plus to go bottom, and your down would be minus minus, minus minus, right? Minus minus to go up. So once you swap first and the last, now your up and down would be pointing to second and the second last. So then you keep on doing this swap process. So essentially at the end you would get a reversed array. So yeah, and at the end just return your grid. In the second problem, you are given an integer array num sub size n, and these numbers are essentially the permutation of numbers in the range 0 to n minus 1, right? And it says you may swap elements at index I and j only if the bitwise AND operation of nums I and nums j equals to k, where k is a non-negative integers, right? And you have to return the maximum value of k possible such that the array can be sorted in a non-decreasing order using any number of such swaps, right? And we can swap if the bitwise AND is exactly equals to k, right? And if the nums is already sorted, we just return 0, right? So if you notice here, the numbers given are in the range of 0 to n minus 1, right? So once you sort it, it will look like 0, 1, 2, 3, 4, 5, 6, and so on, right? Like let's take this as an example. In this test case, your number given is 0, 3, 2, 1, right? So once you sort it, it would look like 0, 1, 2, and 3. See, 0, so once you sort it, it would be 0, 1, 2, and 3, right? So see, 0 and 2, they are already present at its correct place, because we wanted 0 should be present at 0th index, 1 should be present at 1 index, number 2 should be present at the second index, and so on, right? So see, 0, 1, 2, 3, this and this is already present at its correct place. The only number which is placed at incorrect place are 3 and 1. I claim that your answer would be AND of these two numbers. I mean, so in this case, it's just two numbers, but let's say you are given, the large array size. Just find those numbers which are present at its incorrect place and take a AND of that, and that would be your answer essentially. Uh, let's see how this series is correct. So once you sort it, we know that 0, 1, 2. Once you sort it, we know that these numbers would be present, like this number would look like this, and this is your index 0, 1, 2, 3, and so on. So see, if the number is already present at its correct place, why I have to swap it? I won't be swapping it with anyone because that is already placed at its correct place, so no need to touch it at all. Just find those numbers which are present at the incorrect place. Like for example, in this test case, the number was let's take the last example, 3, 2, 1, and 0, right? 3, 2, 1, and 0. So index are 0, 1, 2, 3. See, all these all these four number are present at an incorrect place. So essentially, you have to kind of touch these number at least one number of time, right? You have to touch this number at least one, and as soon as you touch this, for touching means you have to do a swap operation with this number. If the number is not present at its correct place, it means that you have to keep this number at least one in your swap operation. And we know that in swap operation you have to do something A and B, right? A and B. So these numbers is at least included in this swap at least one number of times. So your answer would be, and that explains why your answer will be and of all numbers, all incorrect place numbers, right? Because you have to touch at least one number of time. So yeah, this is a pretty easy problem. Let's see how we can write code for it. Code of second problem. So you are given nums and this is your size. So initially what I did, I tried to find all the numbers which are present at the incorrect place. So I just went from index 0 to n minus 1. I just checked if my current number nums of I is not equals to I. If that is true, it means that this number is not present at the correct place. So I just push this number into the incorrect place numbers. So I created an array called incorrect place number that essentially keeps track of all the numbers which are not present at the correct place, right? So correct place means your number I should be present at the ith index. So just found all those numbers which are not present at the correct place, insert it in this array, and at the end just check if the number is empty. If the array is empty, means that all the numbers are already present at the correct place, means all are sorted. So the number is in the form of 0, 1, 2, 3, 4 and so on. So in that case return 0. Otherwise you just do a AND operation of all these numbers. So this is my answer, all AND of all the numbers. Initially it would be the first element and keep going on the second elements onward and just do AND operation. I mean, so essentially it's a AND operation of all these numbers, and at the end return your answer. So yeah, this is the code of second problem. Now let's look at the third problem. In the third problem, you are given two integer array value and limit, both of size n. So initially all the n elements are inactive and you have to activate them in any order. So there are three steps to follow. So let's see what are these three steps. So the first says that to activate an inactive element at an index I, the number of currently active elements must be strictly less than limit of I. What it means, so let's say you want to activate element I, right? So by the time you're already activated, I mean the numbers which are already active at a moment, let's say that number is x. So you can activate this particular number which is present at index I only if your your total currently active element is strictly less than the limit of I which is present, right? So this is the first thing to follow. Now the second point says when you activate an element at index I, it adds value I to the total activation value. So essentially let's say this is your answer. So because you have to return the maximum total you can obtain. So let's say your total is initially something is 0. Once you keep on activating these numbers, your total would be incremented by value of I. So that's essentially what this second point says. It may seems a bit complicated. I don't know why. I mean, the wording is not pretty straightforward, but it simply says that once you activate index I, just your your answer would be incremented by value of I. Your total would be incremented by value of I. That's it. Now the last point says after its activation, if the number of currently active element become x, right, then all the elements j whose limit is less than this x is permanently inactive. Now the third, so what in simple terms what it says, let's say you activated the current index I, right, and after that your total your currently active element become x. So now all those numbers, I mean all those elements which has the limit less than or equals to x would become permanently inactive. That's what. Now at the end you have to return the maximum total you can obtain after choosing the activation order optimally. Let's take first test case. So in the first test case you are given 3, 5 and 8 as a value and the limit are 2, 1 and 3, right? So the most optimal order which is chosen is 1, 0 and 2, means first activate number element present at index 1, then index 0 and then at index 2. And since for any of the activation process you have to follow these 3 points, right? So let's say if you are following these 3 points, so we know that in the first point says you can activate only if your total count of active elements is strictly less than the limit of I, which is true because this is the first element which you want to activate. So the total active before is 0 because there is no activated numbers before. So 0 is less than limit of 1, which is true, means that we can activate it. So we can activate it, and the second point says that once you activate it, your total answer is incremented by value of I. So the total is 5. Again we followed the second step. Now the last point says once you activate it, if there is a number which is already active but whose limit is less than or equal to x. So once you activate it, let's say your total count become x, but the limit of those active elements are less than or equal to x. Now then you have to make it permanently inactive, right? So once you activate the first element, your total count become 1, right? The count after become 1. The total count of active element after this activation process become 1. But if you notice that that number has the limit of 1 itself, so you have to make it permanently inactive. So it's kind of activate and then make it permanently inactive, right? So once you make it permanently inactive, now we gone, like we went to activate the number present at index 0, right? So what will be the active before? Active before is 0, because you like in the first activation process it become active, but immediately after it become inactive because of the third condition. So like when you start the activation process at index 0, your active before is 0, though it was 1, but again it becomes 0. So now it is 0, then you have to make it active. Now since this limit is, if you notice here, the limit is 2, right? And since there is no element who followed the third condition, so means you don't have to make it any number permanently inactive. So the total is 8, 5 plus 3, this is 8, and total inactive element is that number itself, the first activated number. Now same, we follow the third now like the third step to activate the number present at index 2. So before this process the total active element was 1. After this process it become 2, and once it become 2, if you notice here, the element which is present at index 0 has the limit of 2. Now it become permanently inactive because of the third condition. And once you do that, since you activated this number itself, so your total would be 8 plus 8, 16. 16 is your answer, right? So actually this is a I would say implementation problem. Just implement what it says. This third problem is pretty non-intuitive problem, so I'll explain it through the code itself. You would understand it better if I explain it through the code, what I feel, right? So you are given two arrays, right? Value and limit. So this is my length. I created a vector of pair of int comma int that essentially stores limit and negative value. Let's see why. So I created a pair of int comma int, limit and negative of value, because I want to sort these collection based on the limit. I want the minimum limit to become first and keep on increasing so on. But addition of that, I also want for the same limit. Let's say there are three numbers who have the same limit. I want the maximum value to come first, right? Because if I if I push only value, the sorting will be based on the minimum first, right? Minimum, but I want the like for the same limit I want the maximum value to come first, so that is why I inserted the negative of the value, right? So this is my collection, then I sorted it. Now this is the most important part, the left index. So see, if you have noticed, this problem is pretty much same as the job sequencing, problem. This is a pretty famous interview algorithm problem. This problem is a variant of the job sequence, is just additional overhead. Now that overhead was to that you have to keep track of those number who are become permanently inactive after the activation process. So once you activate it, you have to make some numbers permanently inactive, right? And those numbers whose essentially the limit is lesser than the total current count of the active numbers. Now that is the additional over. Otherwise, this problem is mostly the same as the job sequencing, right? So, because of that, to keep track of the left index from where the good range is start. So the left is essentially the left index of the good range. Means before left, the numbers before left are permanently inactive. That's the definition of the left index. Now I created a boolean array of active, which essentially keep track of the active element. So if active of I equals to 2 means that the ith index element is active. If it is false, it is non-active. This is my answer. This is my current count. I'm going through numbers from 0 to n minus 1. Now my current limit would be a of I dot first, right, after sorting, but the value would be negative of that, because I inserted negative while pushing it into the array. So that is why my limit is same, but the value is negative of the inserted number. This is my limit, this is my value. Now I checked if my current index I is a part of a good range, means I should be greater than or equals to left. Now we had to follow 3 points, right? In the problem statement there were 3 points we had to follow. The first point was you can activate a number only if its limit is more than the total count of active elements. That's exactly what I have checked here. I just checked if my limit is more than the total current active count. If that is true, just it means that we can activate this number. So activate it, um, mark it as active of I equals to true. Now the second point was once you activate it, your total answer is incremented by value. So that's exactly what I have done here. Your answer is incremented by value. Now the third point which we had to follow is that once you activate it, let's say your total active count become x, we have to mark all those active numbers whose limit is less than or equal to x permanently inactive. That's exactly what I have done. I just so I'm going from the good range, that is start from index left. So while left is less than n and a of left dot first, this essentially gives you the its limit, the limit of the number present at index left. If that is less than or equal to x is the current active count. If that is true, just make it permanently inactive. And just check if that was active before. If that was active, your active count become minus minus, and you can add you can also add here active of left equals to 0, but that is not required in this problem. I mean that information is not required, so I just didn't mark it as false. I just decremented my count because count is the one, I mean count which what you I mean like you are interested in. Your current count, your total count become minus minus because that is become permanently inactive, right? I'm keep on going, right? And yeah, that's all, and at the end return answer. Yeah, this is the code of third problem. If you find the video helpful, please subscribe and share my channel with your friends. Thanks for watching. Have a nice day.